Perhaps a little bit darker. What's up, Brave? Oh my god, no. What's up, Brave New World? It's Joshua again. What's up, Brave New World? It's Joshua again here with a brand new video in which we are going to bring you a brand new episode of this section in my channel that I am starting to enjoy, to be honest. And that is this particular section in my channel called Astronomy Support. What is astronomy support? Well, it's a section in which I take a variety of questions from this particular book by Dr. Isaac Asimov, the author of I, Robot, and among other books. And what do I do after that? Well, I share that information with the world by reading that out loud. And I would like to give a shout out to the last person who kindly left a reply in one of my latest videos in which I directly asked the viewers, help me decide what video to make next. And one person said that one person selected the number 12. So let us have a look at the topic of today, shall we? And I would like to ask and wonder, the number 12 is, what is mass? Before we start answering this particular question, I would like to give a quick shout out to all the people, to that person in particular, who so kindly replied to my question, and to that I have nothing but positive words. I will write down your name later when this video is edited, and of course I'll make sure to include it right here. Thank you so much for answering, alright? I totally mean it. So, the question number 12 is, what is mass? Alright? What is mass? Basically, it's this. Before I even read anything in this particular chapter, I would have to say that mass is this particular property of matter that can be measured by how much mass and how much muscle mass by a person or a being or an object has. Alright? In this case, we are talking, for example, about something that can be measured with kilograms, tonelates, tons, maybe grams, and probably pounds. Alright? Pounds. US, I'm trashing you again for your refusal to adapt to metric system. So, let us continue, shall we? According to Dr. Isaac Asimov, it says that in order to find out something more about the Earth, it is useful to decide what we mean by the word mass. So, before we can do that, we must also ask what we mean by weight. Correct me if I am wrong, but I believe that can be measured by this particular unit called newtons, right? One more time. Do correct me if I am wrong. I'm totally serious, alright? Any kind of correction is totally welcome in this particular show in which we talk about astronomy and other things, alright? So, let us continue, shall we? So, in order to find something about Earth one more time, it is useful and important to decide what the word mass means. Although, before we can do that, it is also necessary that we define the word weight. Weight is the result of the pull of the Earth on some particular object. That means how an object is affected by gravity. Alright? Some objects are pulled with such force that it is hard to lift them against the power of gravity. That means lifting something or grabbing something with your arms and lifting it up. For some reason, this reminds me of this particular sport which has an official section in the Olympic Games called weightlifting. Let us continue, shall we? So it says, some objects are pulled with such force that it is impossible or hard to lift them against the power of gravity. Such objects are heavy. Heavy. Remember that word with me. Heavy. 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 Other objects are pulled with less force. They are easier to lift and are therefore light. We measure the weight of any object in kilograms. Oh, really? I thought it was mass. Correct me then. 1 kilogram is equals to 2.2 pounds in American measure, which is a rather horrible one, illogical and totally bogus. That makes no sense and makes everything much more difficult. According to Newton's law of gravitation, however, the pull of the Earth varies with distance. The Earth's pull acts as though it is concentrated at its center, and we are on Earth's surface, which is 6,350 kilometers away. I suppose that by that number you are referring to the diameter of the Earth, or maybe the radius. For the most part, we are not aware of the pull of gravity changes. After all, we always stay at just about the same distance from the Earth's center. And that is kind of debatable because in one of the previous episodes, we discussed that while it's not flat earthers, this message is aimed at you and it has the total intention of trashing you. Yes, the Earth is not a perfect sphere, but neither is it an hexagon, a square, a cube, or anything regarding any flat object. It is not. It is a sphere. For the most part, we are not aware of the pull of the gravity changes. After all, we always stay at just about the same distance from the Earth's center. Well, he said just about. Therefore, it means it is approximate and rough. After climbing to the top of the highest mountain, or descending to the depths of the deepest ocean, doesn't make much of a change, so we usually think of weight as a force that doesn't change. The force of the Earth is something different, alright? So basically it's the gravitational pull, alright? It is the gravitational pull, and it is something that can be measured by how hard it is to lift an object from the ground using our sole force. But if we were to move to a height of 6,350 kilometers above the Earth's surface, we would be twice as far from the Earth's core as we are now. And the pull of gravity would be reduced to multiplied by 2. It means 4 times. What is the rest? It says. What is the rest? It says directly. If we could step on a scale at such height, we would find that we weighted only a quarter of what we weighted on the Earth's surface. Above the Earth's surface. Isaac Newton, you probably have heard of him, who worked out the laws of motion in 1687, looked for a measurement like weight that had nothing to do with the pull of gravity and would therefore not vary with distance from the Earth. If one object is heavier than another, it is because the first object is pulled more strongly by the Earth. Is there another way to judge this difference? I bet it is, and since we are reading a book by Mr. Isaac Asimov, I totally believe that it is totally true that such measurement exists. Let us continue, shall we? Alright. Newton maintained that the speed of an object can be increased or decreased or altered in direction only by the application of a force, and that a heavy object requires a greater force than a light one. That sounds sensible, right? That sounds sensible and that makes sense, right? It sounds logical, actually. Let us repeat that paragraph one more time. Newton maintained that the speed of an object can be increased, decreased, or altered in direction only by the application of a force. And a heavy object requires greater force than a light one. That sounds correct, all right? And it sounds logical. That would be the word I'm looking for. That sounds logical, to be honest. This is actually the common experience of human beings. Suppose, for example, that you have a basketball resting on the ground and you wish to set it in motion. What do? That's not hard. A push with your finger will do the trick. And that totally makes sense. And that totally sounds logical. And once the ball is moving, another push will change its direction or stop it. Correct me if I'm wrong, physicists, but I believe that is called inertia. Do correct me if I'm wrong, please. If there is a physicist or an astrophysicist watching this, please correct me in my comment, right? In this show, Astronomy Support with Dr. Isaac Asimov. Spoiler, I'm not Dr. Isaac Asimov. Any kind of correction by any person who is capable of knowing stuff is absolutely welcome, alright? This is actually the common experience of human beings, Suppose that you have it and you have a ball resting on the ground and you wish to set it in motion. That's not hard because a push with your finger will do the trick, and once the ball is moving, another push will change its direction or stop it. Now, suppose you have an iron cannonball, the same size as a basketball, that is resting on the ground. It is much heavier than the basketball. If you semicolon. So if you try to set it in motion, you will find it requires much more effort. And once it is moving, you will find it takes much more force to stop it or change its direction of motion. The resistance of an object to changes in motion, it's inertia. Inertia. I was not wrong. It is inertia. The resistance of an object to changes in motion is called inertia. And the quantity of inertia that an object has, it's called mass. So the difficulty that an object has in order to change its direction, that is mass. I think I am understanding that perfectly because I immediately assume that a mass could be measured with kilograms and grams. Or pounds if you are from the US and you use that horrible system that not even the UK uses anymore. So, let us continue with the next one that says, mass, like weight, is measured in kilograms. Oh, so I was totally kind of wrong in assumption, I guess. So one more time, mass, like weight, mass is measured in kilograms or pounds, in kilograms or pounds, which is actually a mistake, but scientists are stuck with the habit. I was more or less right. Thank you, Mr. Asimov. It can be measured in one of two ways. Number one, by determining weight, provided you take into account the strength of the gravitational field you are working with. Or, number two, what does it say here? Oh, shucks. Wait. In which case, the gravitational field doesn't count. The two methods seem to have nothing to do with each other, but they always give the same answer. So gravitational mass and inertia mass are the same, a fact that puzzles scientists. I have to say, that's quite an interesting factoid, Wait a second. There is something I'm gonna do. Let's see if... it's working. I'm trying to erase the microphone out of the way. God damn it. Yes. So one more time, the thing that I wanted to express and for which I'm so glad the microphone is out of sight was that it seems that mass and weight are not the same. It basically means that it is the difficulty to lift an object against the gravitational pull of the surface on which it is standing up or on which it is lying, alright? I think that's it for the moment. I think that's it for today's episode of today's episode of Astronomy Support with Dr. Isaac Asimov. Question number 12. What is mass? I hope that answer wraps it up. Well, no. I hope no. that wraps it up, and we finish it right here. Alright, thank you so much for tuning in, and I'll see you later with another brand new episode of Astronomy Support with Dr. Isaac Asimov. And by the way, needless to say, of course, I am not Dr. Isaac Asimov, just a fan. Farewell and peace. Bye.